So hello, I hope everybody can hear me. My name is Hahnekamp. I'm an independent software engineer, and this is already my second talk at this meetup. My first one was last June, where I talked about type safety in JavaScript applications. And this time I want to go some levels deeper, namely to the engine. So the engine is actually the thing that executes our JavaScript code. And I don't want to talk too much about the internals, although it might be, well, it is really interesting and fascinating. But this talk is more from the perspective of an application developer, so somebody that is using JavaScript to write applications. And there I think the question is more, how much do I as application developer need to know in order that the engine runs my code properly and fine. And I want to start with a little code example. So it's more or less Chrome. The font size is large enough, I hope. And as you can see, I have here 4 objects that represent characters from Star Wars movie with the first and the last name. And I'm putting them into an array which contains 8 elements. Okay. Test. Passed. And I further have a function called getName, and I'm now in particular interested in how this function behaves. And what I'm doing now is that I'm calling this function 1 billion times so that I get a decent number. And I'm, for measuring the execution speed or the time, I'm using the time commands from the console object. So I'm running this script now, and it tells me that it executed in 1.3 seconds, which doesn't mean so far. But if we consider now that this script here is a part of a larger application, and the objects are coming from a database, for example, a schemaless database, then it might be quite possible that somebody adds a new property to one of these objects. So, for example, with this object Han, we can add a property spaceship and call it Falcon. It's hard to type with one hand. So, okay. I'm executing this code again. And as I can see, we are now up to 2 seconds. So this is actually a huge performance drop, about 50%. And the question is, why is that the case? One might argue that I have added a third property to an object that held 2 properties, which is 50% more. And it could be, for some reason, the reason for this performance drop. I mean, if I want to verify my theory, then it would be quite easy. I only need to add these spaceship properties to all the other objects, and the performance would drop even more. So if I'm doing this now, and I execute the code again, and for some reason I am actually at the performance we had with the first run. So this wasn't the reason. In real life, the question is now, do we really want to investigate into this problem? Or do we say, okay, if it runs 2 seconds, not a big problem, we skip it and work on some other tasks. Given that we do that, the application is still used further, and it's quite possible that other properties are added. So somebody could start saying that Luke needs a job property because he's a Jedi. For Leia, we could add a gender property, where we're saying she's female. And for Obi-Wan, we could actually add a retired property because he doesn't do anything anymore. And we say it's true. Now if we run that code again, the performance even increases. Now we are actually at 200% of our initial run. Now the question starts again, should we deal with this or should we skip it, should we ignore it? And let's say our users don't really complain, so we decide that we ignore this problem. But what now could happen is that somebody says, well, actually a very important character is missing here, and we add this Yoda, and for some reason we don't know the first name of Yoda, we only know the last name. So I'm saying, okay, just the last name. And I also have to add the new object in my array. Now I'm executing it now. Takes a little time. My laptop gets louder, so there is quite some work. Yeah, and for some reason we are unfortunately up to 9 seconds. So now I would say it's really time that we investigate what went wrong here, and because we simply cannot ignore this issue anymore. So I think it's time that we learn a little bit more about actually the engine itself. And first of all, the question is, what is an engine? So as I already said in the beginning, the engine is the part that executes your JavaScript code. So it takes the source code and executes it. Nothing special. It usually comes bundled with your browsers, and each browser has their own engine. And so with Google Chrome we have V8, Safari has JavaScript Core, Microsoft's browsers currently do have Chakra or Chakra Core, which is the open source project, and Mozilla has SpiderMonkey. And you should not mistake the JavaScript engine with the rendering engine. This is something completely different. And what's also very important to know, I mean, usually JavaScript is interpreted, and until the release of Google's Chrome or V8 engine, the engines only were simple interpreters. So by saying that, what has changed with V8? Well, usually these days, all modern engines are equipped with a compiler and an interpreter. So the interpreter takes the source code during the runtime. It starts to execute it immediately, and what is special here is that it executes your source code on the fly. And with a compiler we have the so-called compilation phase, where the source code is first in JavaScript. It is first compiled into machine code, and with the machine code, the advantage of the machine code is that you can execute it directly, so you don't need any interpreter or the compiler anymore. And additionally, the compiler can also make some optimizations during the compilation phase. This is also very important. So the big advantage of the compiler over the interpreter is that the code execution is faster. The disadvantage is that it takes some time because we have the compilation phase. And with the interpreter, it's the opposite. So the interpreter can really very fast start up your application, but the execution itself is slower. And the basic idea with the modern engines is that we want to combine both of the best of both worlds. So we want from the interpreter the fast application startup, but we also want the fast execution that the compiler can give us. And how can this work? Well, considering a real life example, so let's say we have a web application, the browser is requesting our JavaScript source code. It doesn't matter if the source code is minified or whatever, it simply is JavaScript. And the engine usually starts off with the interpreter, because we want that the application starts immediately. Now additionally, the engine itself now monitors what the interpreter actually does and what code parts are executed very often. And the code parts that are executed very often are also called the hot path. And usually this hot path, or the code parts, became candidates for the compilation. So after some time, when the engine says, okay, I have enough information, we can now start with the compilation, it triggers the compiler. And since the compiler is only started after some time and and compiles the code parts that are used very often, we also call this the just-in-time compilation. What's important, the interpreter still continues, so while the compilation is going on, the interpreter still runs, so your application is still executed. But once the compiler is finished, the engine takes the machine code and uses or executes the machine code directly and skips for the compiled code part the interpreter. And as I'm showing in this chart, there are multiple optimization steps. And there is one particular optimization pattern that is very powerful, and I think that we should all know about. And this optimization step is called inline caching. And if I would have to describe inline caching in one sentence, then I would say it's actually the try to integrate static types during the runtime, which is quite a tough task, as you can imagine, and of course it's not very safe. And I also want to show how inline caching is working by using our example of the Star Wars character movies we had before. So if we are now looking at the situation or scenario, it is when the interpreter is running, we have our 4 objects, we have our function, and these objects are equipped with the property first and last name, and they are passed as arguments to this function. So what the interpreter now has to do is, since JavaScript is not static typed, you can pass actually each kind of type object you want, and the interpreter now has the hard task to search for this property. And if we think that in JavaScript we have this prototype chain, and the property can be somewhere, we also have getter methods, we have proxies and other things. So this property lookup is really quite an expensive task. And therefore, no wonder that, that the execution is very slow. Now with the release of V8, something new was introduced, namely the concept of a hidden class. And what the engine now does, it tries to assign a so-called hidden class to each object. And the criteria if objects share the same hidden class is that they must have the same properties, but the properties must also be in the same order. And since this is the case, so all of our objects have a property first name is on the first place, last name is on the second place. They all share this hidden class, the same hidden class. And additionally, on the function call position side, the engine now is recording the parameters that are passed to this function, and records actually the hidden classes that are executed, that are passed. Still, as we are in the interpretation phase, the code is slow. So if the engine now decides that it is time to compile this function getName, but because it is called very often, in our case 1 billion times, it passes the function as well as the profiling information it has onto the compiler. Usually, or in V8, it does not pass the actual JavaScript source code, but some bytecode it already got from the interpreter. Still, the compiler now has, first of all, the function it has to compile, and it also has the information how this function is used. And what it does now, it says, okay, I see that you are only passing me this hidden class P1. So in that case, I actually don't need to search anymore for the property because I know it's just there, and I only return it because the engine or the compiler knows already where the properties are in these classes. So the situation now looks like following. We have an optimized function that also works with a hidden class and doesn't need to look up the property anymore. This is how inline caching works, and this one's called monomorphic inline cache because the function is called with a single hidden class only. So there might be a situation, and that's what we've experienced before, that there are more hidden classes. So in our case, I have added this property spaceship to the object Han. Now our engine said, okay, this is a new property, so it cannot be P1 anymore, and it has to create a new hidden class. In this case, I call it P2. And compiled code, or the optimized code, now has to make some additional steps. It first has to check if the past object is of type P1, then it returns the property it knows from P1, or if it is from P2. And this results in a slight performance drop, as we have seen in the beginning, about 50% in our example. Saying this, again, there is this monomorphic type where only a single hidden class is passed. I have here some kind of duration. We have the polymorphic inline caching type, and there it only applies if the class amount is 2 or 4. And execution time here is a little bit slower. But starting from fifth class, so if your function is getting more than 4 hidden classes passed, then the inline cache switches over to a so-called megamorphic inline caching. And what's done here is that it actually really remembers the first 4 hidden classes that are passed, but for all the other ones, it has to look up the properties in a more global map. So it still does not need to search for the property every time. There is a map where this is all stored, but still this lookup method is quite expensive. And as we have seen, this is where we went up from 2.4 seconds to 8. So as we now know what the problem is, how can we solve it? Just to verify again, we have here our 5 objects, and as I have said before, starting with 5 objects, you are in a megamorphic inline cache, which is a drastic performance hit. And what I have to do now is that I have to drop this schemaless feature that I have from the database. So what I have to do, there are many options, but this is the option I would prefer, is that we create a class person, and we add in the constructor of this class all properties that are actually possible. I'm doing this right now. Entschuldigung. Yeah, thank you. Okay. Spaceship. So as I said, I'm now adding all possible property to this constructor, and I'm assigning them. So I'm saying this first name, and so on. And since I think we are already out of time, I'm just calling the existing solution. So this is as it looks if I would have more time to write it. So we have here our constructor, and we are calling here, or we are instantiating here these classes. And as you can see, it does not really matter if we are setting the property to null. What's important is that the properties exist and that they are in the same order. And if I'm executing this code part, then we see that we are again at this speed of 1.3 seconds. Hope that's clear so far. And so we come to the final last slide. So my final advice, as I have shown now, is if you can use classes instead of object literals. If you can't, there are other ways. You can use object assign, but with object assign you have to be a little bit careful, since object assign internally adds the properties sequentially. So it can be the case that you have the same properties, but they are not in the same order. then you still have a problem. Furthermore, use a transpiler that allows you to program, or that transpiles to JavaScript, but allows you to develop with static types. TypeScript might be a good option for that. And last but not least, if you're interested in the engines, it's quite good to know what they are doing, but please never try to outsmart the engine or trick it in some ways. It's always a bad idea. And by that I say thank you und danke fürs Zuhören.